Okay, Algebra 1, I'm going to go over your study guide with you, a few problems here. So when I look at this problem, the first thing that I'm going to notice is who the parent function is. And the parent function is the absolute value of x. I should know right off the bat which points are on this function. If I plug in a -2, -1, 0, 1, 2, I get all positive numbers back. So I would plot those points for my original parent function, and I'm going to make that a dashed function because it's the original function. Then I notice that there's a transformation on the inside. That's an IHOP, so it's a horizontal transformation. It's going to be a horizontal shift to the right 2 because we do the opposite of what it says. That would mean that I should add 2 to all of my x values. So I could go there and add 2 to each of these, and I get 0, 1, 2, 3, and 4. Okay, then I notice out here, that's on the outside of my parent function, so it's vertical, and it's multiplying, so it's a stretch, because remember, OVSA, it's on the outside, it's vertical, and it does the same as it says, so it's a vertical stretch by a factor of 2. That means that we're going to multiply all of our y's by 2. So my new points would be 4, 2, 0, 2, 4. So if I plot this, I'm going to be at the point 0, 4, at the point 1, 2, at the point 2, 0, at the point 3, 2, and at the point 4, 4. And that is my new function. All right, the next thing I'm going to do is look at this function. The parent function is x squared. I know who my original points are on x squared. I can plug in a -2, a -1, 0, 1, 2, and out comes 4, 1, 0, 1, 4. All right, if I look at this, this is an IHOP right here. It's inside of the parent function, so it's horizontal. It's going to do the opposite of what we think. Because it's multiplying, it is a horizontal stretch by a factor of 2. This is on the outside, so it's affecting my verticals. It's going to do the same as what it says. It's adding or subtracting, so that's a vertical shift, and we're going to move everybody down 3. So that's like subtracting 3 from all of my y's. So here I go. My x's I'm going to times by 2, and my y's I'm going to subtract 3. So I have a -4, a -2, 0, 2, and 4. And then I have 1, -2, -3, -2, 1. So I plot these points. I have the point -4, 1. I have the point -2, -2. I have the point 0, -3. I have the point 2, a -2. And I have the point 4, 1. And there I have my new function. All right, this next guy here, the parent function is the square root of x. And I know my original points on this function. I can only plug in positive perfect squares, so I'm going to plug in 0, 1, 4, 9. That gives me 0, 1, 2, 3. That's an IHOP. It's inside of the function. It's going to change my x's. It's horizontal, and it's a shift because I'm adding or subtracting, and I'm going to go to the left 2 because I always do the opposite. That would be like subtracting 2 from all of my x's. So I have a -2, -1, 2, and 7. This negative on the outside, remember, is a reflection. Because it's on the outside, that means we're going to change our y's, which means we're reflecting over the x-axis. So we need to multiply all of our y's by a -1. So 0, -1, -2, and -3. So if I were to plot these points, I'm at -2, 0. That's the beginning of your square root function. -1, -1. 2, -2, and 7, -3. So if you take a look at this, you'll notice that your function was not only shifted to the left, but it was also reflected. All right, now let's write a function given the transformations. We want the square root function that reflected over the y-axis. So that means I'm changing my x's and then shifted down 4 units. That is my new function. The absolute value function vertically stretched by a factor of 2 and shifted to the left 3, so we're going to do the opposite of what that one says.